Okay, we've made it to the last part of our Savvas Topic 1 review for 8th grade math. And the last section that we are reviewing for this is going to be scientific notation and standard notation. Okay, so let's start with this first question here. For us, it's number 15. If a calculator displays the following on its screen, 1.47 EE, or sometimes it's just 1E, 12, what is this number in scientific notation? Well, a calculator does not have that many spaces, right? So instead, it will give you this message. And what that really means is that this is scientific notation. It means that it has 1.47 times 10, and that exponent is 12. And that's the way we write it in scientific notation. Remember, scientific notation, that first number has to be higher, 1 or higher, between 1 and 9, right? It can't hit 10, can't be less than 1. And the exponent tells us how many spaces the decimal really moves to the left or the right. So in standard notation then, what we do is we take that decimal, that 1.47, and that 12 tells us that we're going to move our decimal 12 spaces. And since it's positive, we're going to make this a big number and move it to the right 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we fill those empty spots with zeros. Now, we don't leave our answer looking like this, though, because that is not really a number because we have two decimals. Numbers cannot have two decimal spots. This decimal we moved to the end. So the way we write our final answer in standard notation is not with any of these waves, not with two decimals. We would write it like this: 147. And then let's count. How many zeros did we actually have? Well, 2 of them were taken up by 47, leaving us with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And technically now, the decimal is at the end. But you do not have to type that decimal in if you're on Savvas. You would just leave it off. You've moved it out. Okay? And so that would be how you would want to put that in. If they ask for commas, remember, you put commas every third number in. So we would count every 3, starting from the back of the number. And this is where our commas would go. Okay. And there's more practice on things like this. So here, this is why we use scientific notation. Look at how large that number is. To make that in scientific notation, we would want our decimal to go between the 4 and the 0 here. Remember, that first number has to be between 1 and 9. So we're going to change this to 4.0 or just 4. And then times 10 for scientific notation. And then we're going to count. The decimal, the hiding decimal that we don't see, is at the end. How many spaces are between our two decimals? Well, let's count. We would have had to move that decimal back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces. And that would be our answer in scientific notation. Okay? Let's do it again. What about 17? In scientific notation, this doesn't work. This is way small. So what we want to do is we want to place our decimal between the 3 and the 2. Okay? We're going to put it right here. So my number is 3.21. We double check. Is this first number between 1 and 9? It is. So that's good. Then we put down our times 10. And we count the spaces between the decimal that's already there, this one, and the decimal that we're putting in. 1, 2, 3, 4, 5, 6 spots. And this is a very small number, right? It's starting with a bunch of zeros. So we put -6 for that. Okay, we're going to keep rolling. So now sometimes we're going to have to do this, right? When we're going to have to add, subtract, multiply, or divide. So My advice to you is to take a look at what's in the middle of the parentheses. So for the one that we have on screen now, 18, there's nothing in the middle. So we are assuming you know that means times. There's a hidden time sign there. So what do we do when we multiply in scientific notation? We multiply our base numbers, 2.5 times 6, okay? And you can use a calculator for that part if you are unsure, all right? 2.5 times 6 is 15. Times 10, we know we're going to have it in scientific notation. So we multiply our bases here, and then we add our exponents. We add the little guys, -2 plus -5. And make sure you either know your integers or you type it in correctly on a calculator if you're given a calculator. So -2 plus -5 is -7. Now we have a problem here. 15 is too high. Remember, we talked about the first number has to be between 1 and 9. So right now, there's a hiding decimal at the end of 15. We have to move that decimal one space in right here. So we need it to be 1.5. Now, if we move the decimal one space back, that's going to be another space that we need for scientific notation. So here's kind of the rule here. Moving your decimal back adds 1 to our exponent. If we move the decimal forward, which we'll have to do at some point, it subtracts 1 from our exponent. So since we moved it back, times 10, -7 plus 1 is going to make it -6. And this is our answer to the question. Okay. We'll keep rolling here. Our next one. This is a fraction. Remember, fractions mean division. So with scientific notation, we divide the bases here. Okay. So we're going to divide 4.26. I'm going to write that down. We're dividing the bases divided by 2, okay? And again, if you have a calculator, you can use it, or some of you can easily do that one in your head. But if you have a calculator, go ahead and use it. You will see it is 2.13. Sorry, bell ringing here. Okay, and then we subtract our bases. Or not our bases, our exponents. Sorry just about that. So we're going to subtract -3 minus -2. Again, if you know your integers very well, you know that minus negative really means add. So we really have -3 plus 2, which a positive and a negative means subtract. So you really end up subtracting in the end. But if you do have a calculator, you could type that in. -3 minus -2 equals -1. So we put times 10 to the -1. Now, do we need to move our decimal like we did here? Well, let's look. Is this between 1 and 9, our first number? It is. So this one is done. We only move the decimal if that number is too large or too small. Okay, our next two are adding and subtracting. To add and subtract, there's no real trick that we're going to use here. We're going to write them out in standard, add them or subtract them, and then put them back in scientific. Okay, so what I mean by that is 2.3 times 10 to the third. I'm going to move that decimal out 3 spots. So it's really like this, 2.3, 1, 2, 3. And I'm going to move the decimal out 3 spots for this one as well, 4.25. 1, 2, 3. The reason I know it's 3 is the exponent. Then I'm going to line these up by the decimal, right? So I'm going to take that 0, put it under here, then 5, then 2, then 4. This says add, so I'm going to add them. So I get my decimal down. I have 0, Then I have 0 plus 5 is 5, 3 plus 2 is 5, and 2 plus 4 is 6. That's standard notation. Now to put it back in scientific, we want to put our decimal between the 6 and the 5. So we have 6.55. Now you can add the 0 at the end, or you don't have to, times 10. And how many spaces did we go back? 1, 2, 3. And this is our answer in scientific notation. It is very similar for subtraction, only we're going to subtract. So let's do it again for subtraction. So 9.8 times 10 to the 6. All right, we're going to move our decimal out 6 spots. 1, 2, 3, 4, 5, 6. Boop. Okay, 3.7 times 10 to the 4th. Let's move that decimal out 4 spots. 1, 2, 3, 4. Okay, now we line them up according to the decimal, and order matters, right? That second one has to be going underneath the first because subtraction is not commutative. You have to make sure that the first one is our top number. Okay, now we are subtracting, see? And so when we do this, we start at the back again. 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 0 is 0. But 0 minus 7, we have to borrow. But we don't have anything to borrow here. So we have to borrow all the way over here at the 8. So 8 becomes 7, which makes this one a 10. But I still need it for the 7. So I'm going to borrow from the 10, make that a 9, and make this one a 10 above the 7. So 10 minus 7 is 3. 9 minus 3 is 6. Now I have a 7 here, right? 7 minus nothing is 7. And 9 minus nothing is 9. So I get this answer. Oh, that's a 3. Sorry, that got smudged together. Now I have to put it back in scientific notation. Okay, so what I'm going to do is I'm going to put my decimal way over here between the 9 and the 7 so that I have 9.763. And once you hit all zeros at the end, you can stop writing times 10. And how many spaces did I end up moving that decimal? Let's look. 1, 2, 3, 4, 5, 6. 6 places is what I moved it. And so this is my answer in scientific notation. Okay, we're to the last two. Story problems for scientific notation. The population of the United States is 3 times 10 to the 8th, and the population of the world is 7 times 10 to the 9th. How many times larger? Okay, keywords. How many times larger is the population of the world than the U.S.? How many times larger means we're trying to figure out how many United States populations can we fit into the world population. That means we are needing to divide. And we're dividing the world population, the bigger one, right? So we would set it up like this. Here's our world population divided by the population of the United States. Okay, and so we talked about this already. When we divide our base numbers. So 7 divided by 3, 7 divided by 3 equals, and you get a repeating decimal. So for our purposes right now, we're going to round our decimal, okay? So we're going to say 2.33, I know we're rounding, okay, times 10, and then we're going to subtract our exponents. 9 minus 8 is 1. This is technically a correct answer, right? This is also a correct answer if I were to put 2.33 times 10 because there's a hiding 1 on there. If it asks you to put it in standard form then, right, that 1 means I would move the decimal out 1 spot, right? its standard form, I move that decimal one spot out, right? If I moved it that one spot, I'd have 23.3 times. Okay, so these are all correct answers. It depends on what the question is asking for and looking for in Savvas. All right, last one. Woo, it's been a long ride. Here we go, though. It says, if the speed of light is 3 times 10 to the 8 meters per second, how many seconds does it take light to reach Earth if the sun is 1.5 times 10 to the 11 meters from Earth? Okay, so we're talking about speed of light, okay? And the sun is shining that onto the Earth this fast, and it's this far away. There's not really a key word in here, but you've got to think about when we're talking about speed and distance, we're talking about multiplication. So this is a multiply problem. So we're going to multiply our speed of light times our distance from the sun. Okay? Now, remember, to multiply, we're going to multiply these base numbers, 3 times 1.5. Okay, and if you don't know it and you have a calculator handy, you can go ahead and use it, right? And you should get 4.5. Okay, so 4.5. And then we're going to say times 10, and we're going to add our exponents here for multiplication. 8 plus 11 is 19. Now, a question like this, you can leave it like this. There's no, like with a 1, there's no hiding any ones or anything. And also, if Savvas wanted you to write it out in standard, you would then have to move that decimal out 19 times. But I don't think they're going to do that here because that's a lot of zeros. That's going to end up with 18 zeros. The reason they might do it on one like this is because you're only moving it out one time. Okay, that is the review for the test for topic 1 in Savvas. If you have questions, please ask me in class or you can email me. Have a great day, everybody. Good luck.